Hello, and welcome back to this session on design pattern. We'll be looking at the observer design pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The observer design pattern is a behavioral design pattern that establishes a one-to-many dependency between objects. It defines a subscription mechanism where one object, called the object or observable, maintains a list of other objects, called observers, and notify them automatically of any changes in its state. The main goal of the observer pattern is to ensure that multiple observers can be notified and updated when the state of the object changes, without the object needing to have direct knowledge of the observers. This promotes loose coupling between the subject and the observer, enabling a more flexible and maintainable system. In the observer pattern, the subject maintains a list of observers and provides a method to subscribe and unsubscribe observers. When the subject's state changes, it notifies all the subscribed observers, typically by invoking a method on each observer. The observers can then perform their specific logic based on the updated information received from the subject. This pattern is widely used in event-driven systems, graphical user interface, and many systems where the decoupling of components is desired. It promotes a modular and extensible architecture, as new observers can be easily added or removed without affecting other parts of the system. Hello and welcome back. In this real-world code example, we're going to see how we can implement event handling using the observer design pattern. We're going to first start by creating an event object, and the event object holds the event type and also the data that the event is pushing. And then we create the subject. I'm going to be calling it either subject or observable or publisher interchangeably because they are the same thing. And this is where the observers are kept. The event handler class manages the observer and handles the notification process. It has two methods for attaching an event type and an observer. And technically what this does is that it checks if the event type exists. If it doesn't, it creates an event type that takes a list of observers. And if the event type already exists, then it just appends observers to that event. And then also, after implementing an attach method, it also implements a detach method which remove observers from an existing event type. It also implements the notification method, which is called notify, and that takes in an event object. And as you know, an event object takes in the type and the data. And so it checks the event type from the observer dictionary. It checks if the event type exists amongst all the observer dictionary. And if it does, then it loops through all the observers and runs their update method and then passes the event object to the update method. So every observer will get the event and then process it appropriately. To create the observers, I'm going to create an abstract class called observer. That's the contract that the observer will be implementing. I've already inherited abstract base class. After that, then I can now create the concrete observer. Now I'm going to start with a button clicked observer. And the button click observer, of course, will implement the update method, which is called when a notification is sent. And it takes in the event. As you can see here, every observer runs the update method and takes in an event. And in this instance, the event is taken in. If that event is a button click event, then it's going to be printing out button clicked and the data that is in the event. And then I'm going to create another class, a mouse move observer that inherits the observer interface. And that also checks if it's a mouse move, and then it prints out mouse move event. Now let's do the usage of this code, the client side. The first thing I'm going to do is to create the observable or subject And then I'm going to also instantiate the mouse click object and the mouse move object, and also attach it to the subject, the event handler that was created here, and pass in the different observers. And then I'm going to fire this event by notifying of an event. An event is a click event. It's send submit button clicked. So the event handler will go through all the events, and then when it finds the event that has a button click, it's going to run that. And this is the class that runs that. Let's look at the code. You can see from the output, it said button clicked. This is the button clicked event, and then it shows the data that is in the button click. Let's run another event. This time is a mouse move event. This mouse move event just does mouse move and then give out the data. And this is the data that is in the mouse move event. So the notify method of the publisher will publish to all the observers, and the observer that will implement the event will capture that notification, and then it will publish it. Let's detach one of the events from the observer dictionary. So we're removing the button click. If we send a message, that button click notification will not be processed by the method because it has been detached from the event handlers. If I comment this out, you will see it's going to show it, but if it is detached, it's not going to run that class. It's not going to go there because it's only going to check with the mouse move observer, and the mouse move observer will not process it because it's a button click event. There are several methods that you can do event handling. You remember that in the mediator pattern, we did the same event handling process, but in a different way. But in this instance, we used the observer pattern to implement event handling, and it handles the event. It depends on what you want to achieve and how you want your event to be handled. That will determine the type of pattern that you will use to implement your code. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with Real-World Code Examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, catch, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video, and you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.